It's lab day, and we're going to try and determine the specific heat capacity of some type of metal. We're going to heat up the metals by putting them in a water bath. Now, when the lab asks you about the water, this is not the water. The water is in a coffee cup calorimeter. So this is a way to heat up the metals. We are assuming that the temperature of the water and the temperature of the metal are the same thing. So when we measure this using a glass thermometer, this will be the temperature initial of the metal. We simply plop the hot piece of metal into the water that's at room temperature. Heat will transfer from the metal into the water. It's going to be an equal but opposite transfer. To determine the specific heat capacity of water, which we all know is capital C, we're going to need water as an energy sponge to figure this out. Since there's going to be a temperature change, we know the equation is going to be Q equals MCAT. That's Q for metal, M for metal, C for metal, and delta T for metal. The delta T is going to be T final minus T initial, and this right here, C, is our goal. So I'm writing down all the pieces that I'll need to figure out this lab. If you're doing this at home, you're going to use these same numbers, so you might want to jot them down. We're going to be able to figure out all this stuff, but except for Q for the metal, we're going to figure out Q for the water and assume it's the same. Since there's Q for water, there's M for water. There's C for water, which again, we all know is 4.18 joules per gram degrees Celsius. We'll figure out the delta T from water by doing T final minus T initial. It's last minus first for deltas. And that's all we need. Every single one of these numbers. How hard could this be? So what we're going to do is go back to the original thing. We have a coffee cup. This is our calorimeter. We make an assumption that no energy goes in or out of it, which is not the best assumption. So I'm weighing the cup, and then I need to put some water in. I want to put about 70 or 80 grams of water. It doesn't matter exactly. So I'll use a beaker to do an estimate. Just fill up to 70 or 80. I have mine right around 70. This can be tap water. You don't need distilled water. And I pour it in very carefully because I don't want to spill water on the scale. And now what is recording is the cup of and the water, which I'll go back and subtract out the mass of the cup to figure out what the mass of the water is. You can't just pour water on a scale. That doesn't work. So now we're getting these numbers down. With these two, I can figure out the mass of the actual water. I have my computer hooked up with Logger Pro and a temperature probe. I have the temperature probe in the cup of water, and now I need to read what the temperature is for this hot water. And if you look carefully, you can measure this to a half degree. So this is going to be plus or minus a tenth. This is right at 89. So I think I end up writing down 89, but it really should be 89.0 because you can get a shifty little tenth sig fig out of this. So I made a mistake here. It really should be 89.0 because you can tell 0.5, maybe like 0.3 on this thing. Now, put your thermometer into the cup, but be careful. If you let it go, it may just fall over and spill water everywhere. Also, the thermometer and the cup of water may not be the same temperature. So I'm going to go ahead and push collect on this thing. And you see the temperature is 22.5. We want it to equalize and stay constant. So you need to push collect before you put in the metal. And in fact, once you push collect, see that green button on the top? Yeah, that's it. Click that, and it'll start building a baseline. What I call a baseline is a nice flat. This will be our temperature initial for the water. I'm telling you, if you put your thermometer in and push go, it may actually drop a little or come up a little bit. The water is coming from pipes throughout the building, and so there may be a little bit different temperature. So now we got a baseline. I got the temperature of the metal recorded. I'm going to take it out and very quickly put it into the hot water, and then I stir. I want to try to knock it over to submerge it, and I just stir around a little bit. I don't have to whip it up into a lather. Don't worry about the graph going all crazy. When I put the thermometer right next to the metal, it got hotter, but that's not really what we want. We want all the energy to leave the metal and go into the water. We want it to be a nice flat line because it's only going to go up 3 or 4 or 5 degrees. And when it does, it's going to stay stationary. It's going to stay flat. So we want to make sure that all the energy is transferred and that all the warm water and cool water is mixed together to be nice and uniform. You're literally only measuring the temperature right next to the thermometer, not to the water on the other side of the cup. So now I got a nice flat baseline. The little jaggedy heartbeat looking thing we're going to disregard. I push the A button and it auto scales it. From this, I'll be able to tell temperature initial for the water, temperature final for the water, and temperature final for the water is also temperature final for the metal. Now I need to weigh the metal. I'll do this at the very end. Make sure it's good and dry. We don't want to weigh water. And I'll put it onto the same scale. Make sure it's zeroed out. We're assuming that the fishing line is negligible. So it's 58.0809. It flip-flops back and forth. Sometimes if it flip-flops back and forth, it's right in between. Just pick one of the two. It's to 4 sig fig, so it really won't make any difference if it's 0.08 or 0.09. So that's the mass of the metal in grams. Now I come over here and I'm going to this flat line right there, anywhere along that flat line, that's temperature initial for the water. We're going to skip the heartbeat part and wait till it gets flattened out. It's still going up on the left side, so wait till it's flattened out. This is temperature final for the water, but it's also temperature final for the metal. That's going to be really important. And as you can see, the water still kept going up even after a minute or so. So you want to give it some time to completely flatline. You can put your cursor right on that flat spot, and on the bottom left, you can read the numbers. So it's going to be, that says 22.54. I think I did it again. I got 22.55. Again, it's not that precise, but it's decently precise. Now I go up here, same thing, put it on one of the higher flat spots. That's going to be 27.28. Those are my temperature final for the metal and for the water. So we're going to jot those down. Mass of the water after I subtracted out those two numbers at the bottom. And then we're going to put in some of the temperatures. It's a lot of temperatures of this. We got to keep it straight. Remember, the hot water on the hot plate is not the water that's on the right side of this page. The water on the right side of the page is in the coffee cup calorimeter. So here's my initial and final for the water. And remember, the final for the water is the final for the metal. That's when the heat stops flowing. Once I figure out T final for the water, I can figure out Q for the water. Q for the water is Q for the metal, but a negative sign. I can figure out delta T for the metal. I'll have Q for the metal. I'll have M for the metal. And then I can solve for C for the metal.